Good day, grade 8. This is Miss George speaking, and today we are going to be solving algebraic equations, right? So before we get started, there are two laws that I want you to keep in mind and I want you to follow throughout this exercises, and that is number one, we want all the terms that consist of variables, or let's say letters, to make it easier for you to understand. So all the terms that consist of letters on the left hand side of the equation, and then constants, or better known as numbers, must be on the right hand side of the equation. So that is what we want to see first, right? And then doing the same thing on both sides. That's the second law we're going to follow. We want to do the same thing on both sides of the equation so that we keep the equation balanced, right? Because if we look at the seesaw and we have the same weight on both sides, the seesaw will be balanced, correct? If we remove 10 k's from the left hand side, we must remove 10 k's from the right hand side so that that seesaw can remain balanced, isn't it so? So it's the same concept. In order for our equation to remain balanced, we need to do the same thing on both sides. Great. Now let's look at an example, right? I have 2x minus 3 is equal to 5. Okay, so our first law tells us that we want our terms that consist of variables on one side, which is our left hand side, and our constants on the right hand side. So let's look at it. Over here, right at the beginning, we have our 2x, right? Can you see that? 2x, that is a term, and then we have negative 3, that is a term, and we have 5. Okay, so we want the terms that consist of letters to remain on the left hand side, right? So I can write my 2x down because that must be that's what I want, must be on my left hand side. I do not want this negative 3 on my left hand side. I want it on my right hand side. Okay, with that being said, we are going to undo what is happening over here. Okay, so we are subtracting by 3. To get rid of that, we are going to say minus 3 plus 3. Okay, so those two values can then cancel out and give you 0. So in that way, we are removing that term from the left hand side. Okay, so remember our second law says that we need to do the same thing on both sides. So because I'm adding 3 on this side, I need to add 3 on my right hand side as well. Okay, so therefore you end up with 2x is equal to 8, right? Okay, great. So now we have 2x. X is not alone at this point. We want x to be alone. That is going to be our aim here. To find the value of x, we need to have x on its own on the left hand side, right? So like I said before, the coefficient and the variable, if it's written like this next to each other, it means that they are being multiplied with one another. Can you remember that? Okay, so you saw over here we did opposite operations to get rid of something. So likewise, to get rid of our 2, we are going to do the opposite operation. And opposite to multiplication is division, right? So I need to know that I need to divide. Okay, the question might be divide by what? The number we want to get rid of is that 2 over there. The 2, that is the coefficient. Okay, so whenever you want to get rid of the coefficient of the variable, you're going to divide by exactly the same value. Okay, so because there's a 2 there, I'm going to divide by 2. If there had to be a negative 3, I must divide by negative 3. If there had to be a 10, I'll divide by 10. Okay, I hope you get the picture now. Right, so what you do on the one side, you must do on the other side because we're following law 2. Right, so therefore, those two values will cancel out and you only have x on your left hand side, and 8 divided by 2 gives me 4. Okay, I hope you all understand, but let's look at the same example, doing it just a bit differently, okay? So now you can see, to get rid of this constant over here, to get rid of this number, you must then do the opposite, okay, by adding 3. But there is an easier way that you can do this, but I wanted to show you how we got to 5 plus 3 on this side over here, okay? I wanted you to see how we got to plus 3 on this side. But another way of thinking of it is, I'm just going to move that negative 3 over the equal to sign, because I don't want it on my left hand side, okay? So let's think of moving that negative 3. Remember, the sign in front of the term gives value to the term. So if I move a term across the equal to sign here, the sign will always change. The number is going to stay the same, but the sign will change, therefore leaving me with 2x is equal to 5 plus 3, because if I move that negative 3 over, it now becomes a plus 3. Can you see? It gets me exactly the same thing, but it saves me one step over there. Okay, so then again I'm going to divide by 2 on that side, and then x is equal to 4. Okay, let's just look at another example before we start on our exercise. So let's have a look at this example, right? Here's my term that consists of an x, right? Here's a number, and there's another number, correct? So the law 1 said that I want the term that consists of an x on my left hand side and all the numbers on my right hand side. Therefore this plus 4, I don't want this plus 4 here. Are you with me? So I'm going to transport, or I'm going to move that over the equal to sign, okay? And when I move any term over the equal side, it doesn't matter the direction. If it goes over the equal to sign, the sign must change. So therefore this plus 4 becomes a minus 4. So let's just write that. So what I have left on my left hand side will be x over 4 equal to what I have left on my right hand side is 9. What was moved over is 4, which now becomes negative 4. Okay, so then let's just simplify that. So I have x over 4 is equal to 9 minus 5, which leaves me with, 9 minus 4, which leaves me with positive 5. Okay, now this might look confusing to you, but like I said in the previous example, we are going to follow, or we are going to do the opposite operation to what is actually happening to x. So right now x is being divided by 4. Can you see that? So the opposite operation of division is multiplication. So therefore you need to multiply by 4. And remember, any whole number can be written over 1. So again, now whatever the denominator is, you're going to multiply by that same value. So if the denominator here was negative 2, you must multiply by negative 2. If the denominator is 10, you must multiply by 10 to get rid of that denominator. Okay, so what you do on the one side, law 2 says you must do on the other side as well. Okay, so over here I will have x alone now, because the two value, the numerator and the denominator, is the same, so they cancel each other out. So I'm only left with x is equal to 20. Perfect. Okay, do you all see that now? Great. So now I'm going to write an exercise down for you, and you are going to try to do them all on your own. Okay, so now you have the exercise, 5 questions. Try it on your own, and then next you will have the solutions of the question, of each question. I will write down the solution so you can check if you've done it correctly. Right, grade 8. So here are the solutions to that exercise. If you look at number 1, it's pretty straightforward. Okay, So all you needed to do was get rid of the number in front of x, and I said that is by dividing by the same value. Okay, the two of them will cancel each other out over there, and it will leave you with 12 divided by 4 gives you 3, right? Number 2, same as in the example, so you need to carry over your number there, your -2, that becomes 15. Divide by the same value as your coefficient, do the same thing on the next side, and then that gives you 5. X is equal to 5. Exactly the same method by number 3. Number 4, let's look at number 4 again. My number I need to carry over. I have 2 minus 1, the -1 becomes +1, therefore giving me 3. And then to get rid of a denominator, I must multiply by a whole number, the same value, okay? So there my numerator and my denominator is the same, therefore they can cancel each other out. What I do on the one side, I must do on the other side, leaving me with x is equal to 4. X is equal to 12. Right, now let's look at number 5. Number 5 can become a bit complicated, but we follow the steps, right? So firstly, we want all our numbers on the right hand side. Therefore, we're taking that +2 over, which becomes -2, right? We all should know that by now. So we can simplify that over there. 8 minus 2 gives me 6, right? So now we have a fraction, okay? We have 3x divided by 4. So like by number 4, whatever our denominator is, our numerator must be the same value. And then whatever our numerator is here, our denominator must be the same value. Can you see that? So we know, because the coefficient of x here is 3, so we know we must have a denominator as 3 as well. Our denominator is 4, so we must have a numerator of 4 as well, which means we are just going to multiply by its inverse, okay? So we're just going to multiply by 4 over 3, the inverse of 3 over 4. It's like flipping the fraction, okay? And what we do on the one side, we do on the other side as well. So everything cancels on the left hand side, leaving me with x alone, right? And then on the right hand side, you have 6 times 4 over 3, which would give me 24 over 3, and 24 divided by 3 gives me 8. Therefore x is equal to 8. Okay, we need to practice and do some more practice all the time to make sure that we understand the concept. I hope you enjoyed this lesson. Bye for now.